In this video we will discuss about rolling motion on an inclined plane. This is an inclined plane of angle theta. A body, it can be a cylinder, it can be a sphere which is moving downwards, and while moving downwards it is also rotating about its axis. Now the reaction force is, suppose N. The weight of the body acts downwards, as you already know, breaking up mg into two components, mg cos theta and mg sin theta. Frictional force acts along the incline in the upward direction. Mass of this body, mass of the body is capital M, and the radius of the body is capital R, which is rolling down an inclined plane at an angle of theta to the horizontal. Now the body rolls without slipping. The condition is the body must be rolling without slipping, because the body will be rolling downwards like this. The motion will be like this and not like this straightwards, slip down the hill. It will be a rolling without slipping. Now you have to first consider the three forces into the weight mg of the body acting vertically downwards to its center of mass. This is center of mass. The normal reaction N on the inclined plane or the normal reaction N from the inclined plane, and the frictional force F acting upwards and parallel to the inclined plane. Now two equations, one for the translational motion as we have always done earlier, one for the translational motion, that will be mg sin theta, we've taken it to be mg sin theta minus F mg sin theta minus F is equal to MACM. The second equation is the rotational equation. We can write it as tau is equal to I alpha. You know the mechanical torque is I alpha. From this, F into R. Now because of this F into R, or the torque due to the frictional force, the body is moving in this direction. The body is moving in this direction. F into R. So Fr. So the torque due to the frictional force results in the mechanical torque, which is used up in rotation of the body. Now combining these two equations, we can get conditions for pure rolling from condition of pure rolling. From the condition of pure rolling, ACM is equal to alpha R or mg sin theta minus F by M. This ACM, we replace the value of ACM here, mg sin theta minus F by M here. So alpha R is equal to mg sin theta minus F by M, which is equal to M Fr square by I. It will be Fr square by I, because we are replacing the value of alpha from this equation. From this equation implies alpha is equal to Fr by I. So alpha is equal to Fr by I into R, that means Fr square by I. So the last part giving mg sin theta minus F is equal to M into Fr square by I. Instead of I, we are replacing it as the radius of gyration, that is mk square. So mg sin theta minus F. So you have to calculate F from it. calculation of F. So calculation of F means mg sine theta is equal to F plus m r square F by m k square, where m gets cancelled out. If we take F common, then r square by k square. That means F is equal to mg sine theta. M gets cancelled out. So taking F common from these two expressions, we get 1 plus r square by k square. So mg sine theta by 1 plus r square by k square. So this is the value for the frictional force for pure rolling. But from the diagram, we all know that the frictional force is equal to mu n. Frictional force is equal to mu into n. That means mu mg cos theta. So if we take the relation as F less than equal to mu mg cos theta, implies mg sine theta by 1 plus r square by k square less than equal to mu mg cos theta, because this is the extreme value for the frictional force. So from the rolling condition, pure rolling condition, we have found out the value of F to be mg sine theta by 1 plus r square by k square. We have replaced F, the value of F here, less than equal to mu mg cos theta. So sine theta by cos theta becomes tan theta, and it will be capital M. Again, M gets cancelled from both the sides. It will be mu greater than equal to tan theta by 1 plus r square by k square. This is for pure rolling. So from this equation we can write the minimum value of mu, that is equal to tan theta by 1 plus r square by k square. This is r square by k square. So the minimum value of the coefficient of friction is tan theta by 1 plus r square by k square. Now velocity are at the bottom of the inclined plane. When the body reaches the bottom of the inclined plane, there is a shift of energy. That means the ball falls for a vertical distance of h. So we can write mgh. The fall in potential energy is mgh. That means that must be equal to the gain in kinetic energy. Here there will be two kinds of kinetic energies. One is the translational and another is the rotational kinetic energy. So half mv square plus half I, instead of I we can write mk square, and omega as v by r whole square. So combining these two, we can get half mv square common from both, 1 plus k square by r square. So again m gets cancelled from both the sides, and the distance traveled by the body along the inclined plane, let it to be s. Take it to be s. The distance traveled by the body down the inclined plane is s. So the relation between, and this angle is theta, so the relation between h and s is equal to s sine theta. This is the relation between h and s. So we replace the value of h here as s sine theta equal to 2ds. So v square 1 plus k square by r square. So the expression for v will be equal to 2gs sine theta by 1 plus k square by r square. 1 plus k square by r square. Again, when the body slides, that means k square by r square must be equal to 0. Therefore v sliding the velocity of sliding, that means without rolling, the block will slide and come down, equal to square root of 2gh equal to 2gs sine theta. So it implies that velocity of sliding always will be greater than the velocity of rolling. This was the velocity of rolling. So velocity of sliding is 2gs sine theta, square root of 2gs sine theta. So velocity of sliding greater than velocity of rolling, always. Now the acceleration of the body. Now the acceleration of the body, when the body reaches the position here and here, the initial velocity of the body was 0. So u is equal to 0. Acceleration is a, suppose. So we can write v square is equal to u square plus 2as. Replacing u as 0, we get v square is equal to 2as. We had already found out the value of v square, that is this one, square of this term. So it will be 2gs sine theta by 1 plus k square by r square is equal to 2as. So the s cancels out from both the sides. So it will be a of sliding, not sliding, a of rolling, a of rolling is equal to g sine theta. 2 also gets cancelled both the sides. So g sine theta by 1 plus k square by r square. Again the condition, sliding condition comes into play when body slides. Again k square by r square is equal to 0. Therefore a sliding will be equal to g sine theta, because if this term is 0, that means 1 plus 0 means 1, so it will be only g sine theta. From this again we can imply the fact that a of sliding must be greater than the a of rolling. Similar to the principle of velocity, in which I found out that velocity of sliding is also greater than the velocity of rolling. The third quantity, time taken to reach the bottom, that is s is equal to half at square, where u is equal to 0. Now t is equal to, from this equation we get square root of 2s by a. We replace the value of acceleration in the equation like this. 2s, what was a? It was g sine theta by, that means it will move upwards, k square by r square. Again, what was the relation between s and h? S was equal to h by sine theta. So we replace s here by h by sine theta. 2h by sine theta means g sine square theta into 1 plus k square by r square. Taking sine theta out of the square root, we get 1 by sine theta square root of 2h by g into 1 plus k square by r square. So this is the value of the time taken to reach the bottom. Again, sliding condition, when it slides, similar case, k square by r square, this is k square by r square is equal to 0. Therefore t is equal to 1 by sine theta by 2h by g. So again, t of implies t of rolling will be greater than t of sliding. If the body slides, the time taken for sliding will be less. Now this is in contradictory to the first two cases of velocity and acceleration, where the sliding part was greater than the rolling part. Here the rolling part is greater than the sliding part. Time of rolling is greater than the time of sliding. Now one note, if you can make, that is, if different bodies if different bodies are allowed to roll down, different bodies are allowed to roll down on an inclined plane, then the body with k square by r square or least k square by r square will reach the bottom first, and the maximum k square by r square will reach the last, but with equal k square by r square for the two bodies will reach together. Equal k square by r square, they will reach together.